This is a recording for Edexcel Further Pure 1, Coordinate Systems 1, the Parabola and Rectangular Hyperbola. Section 1.2, an overview of conic sections. Well, by a conic section, we're looking at the idea of slicing a cone and looking at the shape that's produced when we do that. So, for example, if we sliced through the cone this way with a plane, like this, then we would get some shape which would look something like this, for example. Now, quite difficult for me to draw here, but in a second we'll be looking at a computer program which will do it for us. When we're mathematically talking about a cone, we in fact mean what's called a double cone like this, so one cone on top of another, so that the slices sometimes will go through both the top and the bottom part of the cones. Now let's look at this in a little bit more detail with the aid of a computer program. Well, in this simulation then you can see the double cone and a plane in deep blue which is cutting through the cone, and the shape that we get is indicated in that lime green color. So at the moment the plane is actually parallel with the base of the cone, and you can see that the shape that we get if we look from the top is circular. Now it doesn't matter where we have that plane cutting, I can move it up and down the cone and you can see that it remains a circle at all points. Now what I can do with this program is to change the angle which we're cutting the cone at. So there we are, we've just tilted it over a bit, and now we need to sort of turn round, and you can see that instead of a circle we've got an elliptical shape, so it's an ellipse. I can increase the angle a little bit to exaggerate the ellipse a bit more, so there we are, it's a little bit more elliptical, it's gone away from the circle completely. And again, wherever we are in the cone, it is always going to be an ellipse. Now at the moment the plane is only cutting through one part of the cone. I can change the angle to the point where it becomes exactly the same angle as the cone itself, the slope of the cone. And there it is. And you can see that it's changed from being an ellipse now, which was a closed curve, into an open curve. But again, I can move that up and down. There it is, being moved up and down. And it still just remains that single part of the cone which is being cut. Now this shape is one that you're familiar with as well. This is what's called a parabola. So that's when the angle of the plane was equal to the angle that we have of the sides of the cone itself, so it's equal to the slope of the cone. Alright, let's go back round a little bit, and now what I'm going to do is to increase the angle even further, and as soon as we get up to here, you'll see now that we have an angle which is steeper than the sides of the cone, and now we've got something which is cutting both parts of the cone, both the top and the bottom sections of that cone. So this is a different curve. A parabola has only got one part to it, but this is a curve which has got two parts to it. It's a new one, and this is what's called a hyperbola. So this slide shows those four different curves that we get depending on the angle which we're cutting the cone at. If we have the slice being parallel to the base of the cone, we have a circle. If we increase it slightly, it then turns into an ellipse. The parabola is where the angle of the cone is exactly the same as the angle that we have of the plane that we're cutting with. So those two lines there are parallel, and that it gives us a parabola. And finally, if we go steeper than that, the fourth curve in the family is called a hyperbola. Now if you want to look at that yourself, there's a link there that you can use, and that will allow you to go and have a little bit of a play with that program that I've just shown you. The important thing is then that you realize that the circle, ellipse, parabola and hyperbola are all part of the same family of curves, and they are known as the conic sections. Well, that's the end of this recording. In the next one, we'll begin to look at one of those conic sections, the parabola, in a little bit more detail.